Now let's look at horizontal translation. This time, if we're working graphically, shifting a graph horizontally works in the same way as shifting a graph vertically, only now we're changing the x-coordinates, shifting them left or right, and leaving the y-coordinates unchanged. I'm going to let you do the points on your own, and we're going to skip down to the figures. And there's one tiny little mistake in this line. This isn't a rectangle, this is a triangle. So let's change these words here. Change that to triangle. Sorry about that. And we can go right 2 units and left 1 unit. So here we go, right 2 units. I'm going to take the 3 points on the graph, shift them 2 units right, and then I'm just going to freehand connect these dots. It won't be perfect, but it's close enough. So there's our triangle shifted right 2 units. We had our original triangle 2, 3 here. Shifted to the right, we ended up with 4, 3. Notice the change in the x-coordinate and not the y-coordinate. And then if we want to go left 1 unit, we'll take 2, 3 and pull it over to the left. Same with these other 2. And connecting those ordered pairs together, we can see that this one became 1, 3 at the top. So we can see how that top point moves in relationship to our horizontal translation. We can repeat this process for number 3, and we get 2 more graphs shown here. One shifted right 3 units, so our original function at 1, 1 is now at, negative 1, 1 is now at 2, 1, 3 units over. And then our left shift negative 1 in our new function is now negative 3, 1. So we can see that shifting. The x-coordinate changes, the y-coordinate stays the same. So far everything seems a lot like vertical translations. But when we work with this symbolically, unfortunately it is not the same. Things change. So let's try an example together, connecting the graph with the symbols. Here we have the function 2x minus 1 and its graph. Just like before, we're going to take this graph and physically shift the graph 2 units to the right just by plotting points. We'll take this point here on the graph and shift it 2 to the right. This point here, 2 to the right. This point here, 2 to the right, 2 to the right. And we get a new graph for a new function. So here's my g of x function. The x-coordinate changes, the y-coordinate stays the same. Using the graph, we can fill in a table of ordered pairs. So I have negative 1, negative 3 on my original function, but my shifted function is now at 1, negative 3. And that's represented in that first row. So now we're going to fill out the rest of the table. 0, our original function is at negative 1, but that point gets shifted to 2, negative 1. 1, it's at positive 1, but it gets shifted to 3, 1, so we're adding 2 to that x-coordinate. And then 2, 3 gets shifted to 4, 3. So far we're doing okay. Now we're going to deliberately make a mistake to show that adding and subtracting on x does not do what adding and subtracting on y does. It's not quite the same. So vertical shift upward is accomplished by adding a quantity to y. Vertical shift downward is accomplished by subtracting a quantity to y. We saw this in the previous lessons, f of x plus a number or f of x minus a number. We were just tacking on that shift at the end. It seems reasonable that horizontal shifts would work in the same way. So we're going to try to shift 2x minus 1, 2 units to the right. So let's try to plug in x plus 2. We're adding 2 to the x part to see what would happen. So if we multiply this out, 2x plus 4 minus 1 will give us 2x plus 3. So our new function is 2x plus 3. And this is a linear function. Our slope is 2 and our y-intercept is 3. But let's come back up here to the graph for a second. Where does this graph, our new graph, g, where does it intersect the y-axis? It does not intersect that y-axis at 3. There's nothing there. It actually intersects that y-axis at negative 5. So the y-intercepts are not the same. That means adding to the x will not result in a horizontal translation to the right. So let's see what that original function f does to an input. We're going to write the rule for this function. F of x takes an input, f multiplies an input by 2, and subtracts 1 from the result. When we shift right by 2 units, the x value increases by 2, but the y coordinate remains unchanged. The new x values have to produce the same y values that our original function f did. Let's see what happens when we subtract from x this time. So here, if we subtract 2 from x, multiplying this out, 2x minus 4 minus 1 gives us 2x minus 5, so our new function, 2x minus 5. That was our shifted graph's y-intercept, -5. Let's plug in some numbers and see if it matches our ordered pair table from before. So if I plug in 0 to g of x, I'll get -5. If I plug in 1, 2 minus 5 is -3. If I plug in 2, 4 minus 5 is -1. And if I plug in 3, 2 times 3 is 6. 6 minus 5 is 1. So let's take a look and see if these ordered pairs match up with my shifted ordered pairs. 1, -3, 2, -1, 3, 1, and they do match up. If we graph these ordered pairs, we'll get the function that looks like our shifted graph from above. Okay. For horizontal translation, if we are wanting to shift the graph right by h units, then we're going to subtract h from x. And if we want to shift left by h units, we're going to add h to x. It may seem counterintuitive, but we need to trick the function f into giving us the same y value that would have occurred with the original x value. So let's try another example. F of x is 2x minus 3, and we're going to shift it left 4 units. So my new function will be f of x plus 4. Left 4, we're going to do the opposite, add 4. And then if I plug x plus 4 into my function and simplify, let's see what our expression g will be. 2x plus 8 minus 3. 8 minus 3 is going to give me 5. So my new function, my shifted function g of x, is 2x plus 5. In the next part of our lesson, we'll put this into practice.